Hello everyone again. So in this video I will show you how to calculate expected rate of return and standard deviation or risk using the information provided in our table in our slide. So first of all, I copy everything into Excel. So assuming that we are analyzing the performance of our stocks next year. So we know that our investment performance depends on market in general. So here we have three different possible outcomes for the market. First of all, there are 20% chance that the market will fall in recession, 30% chance that the market fall in have moderate growth, and 50% chance that we have a strong growth. Now under each scenario, our investment will generate different cash flow for us. So if the market is recession, we will receive 1,000. If it is in a moderate growth, we receive 1,200, and finally, in the best case, we get like a 1,400. So with the cash flow generated from our investment, together with our initial investment of 10,000, okay, we can easily calculate the percentage of return for each scenario. Over here with 10,000, you take 10,000. I'm sorry, with the cash flow of 1,000, you take 1,000 divided by 10,000 investment, so the rate of return is 10%. Similarly, with the cash flow of 1,200, now you take that divided by 10,000, the return is 12%, right? And then finally you have 14%. So the rate of return is 10%, 12%, and 14%. Sure enough, you can put 10% here, but believe me, it will save you a lot of trouble if you simply put 10, 12, 14. Okay, we all understand that. Okay, it is the percentage term. Yep, so 10 here is 10%, 12 here is 12%, and 14 here is 14%. Okay, now the reason is that later on when you have to calculate the standard deviation, if we put everything in that kind of percent, the number is so small and it causes you a lot of trouble for calculation. So just leave it like that. So remember that it will save you a lot of trouble. Okay, now let's move on to calculate the expected rate of return. The expected rate of return equal to the sum of the product between probability and the return itself. So basically you will take this column multiply by that column, those two columns. So equal to 20% multiplied by 10% here, it is 2%. Yep, we just like the rule we apply here, everything is percent, so the product we got is also percent. Here's 2%. Now the second one, you take 12 multiplied by 30%, so we got 3.6%, and eventually you got take 14 multiplied by 50%. Here you have 2, 3.6, and 7, right? So all in all, the last step you need to do is to add those three numbers up. So you take 2 plus 3.6 plus 7. So you add it up, it will give you 12.6%. So no big deal, it is right here. It's 12.6%. Okay. Now the next step for us is to calculate the standard deviation. How can we do it? So we have to go through a few different steps. First of all, we have to calculate the deviation of return from the average. Over here it is the individual return, right? This column. And here is the average return, or the expected rate of return for the next year. Okay? So we have to take the difference between individual return and the expected rate of return right here. Let me give it a different color. Yep. So here we take 10 minus 12.6. So the difference is 2.6. Then we take 12 minus 12.6. The difference is negative 0.6. And finally, we take 14 minus 12.6, we get 1.4. So it is how much individual scenario deviate or different from the average or the expected return for the next year. Now, the second step is for us to square the deviation. So over here, we take negative 2.6 multiplied by itself. Yep, give you 6.76. We take 0.6, negative 0.6 multiplied by itself. It is 0.36, and finally 1.4 multiplied by itself. Yep. So here we got the square of the deviation. Let me hide what we don't need. Okay. So now the next step for us is to take the square deviation just calculated and multiply by the probability. So it means we take this column, multiply by that column, right? Okay. So now here we go, equal to the square deviation multiplied by the probability. First scenario. Second scenario is 0.36 multiplied by 30%. And finally, we have 1.96 multiplied by 50%. Yep. Then, just like in the situation of expected rate of return, we add those three numbers up. 1, 2, 3. 135 plus 0.11 plus 0.98. We have 2.44. Now, in terms of math, this number is the variance. Now, in order to calculate the risk, we have to take the square root of 2.44. So, square root of the above number. Okay, now the square root is 1.56. So, let me pull everything back again. Now, sorry. So, let's look at what we have. The 12.6 is the expected rate of return next year under the general scenario, right? On average, we should expect that return is 12.6. The 1.6 here is a standard deviation of the series of return, and in finance term, it is a risk associated with your investment performance. So the standard deviation here is 1.56%. The expected rate of return is 12.60%. Okay, that's how we do it. Okay, another type of problem you have in that chapter, of course, you have to study the CAPM, the capital asset pricing model. So the idea behind that model is for given stocks, the return you should receive depends on few things. One is the market condition, the free rate, and the market return. So free rate and market return is a market condition, right? And finally, it depends on the risk factor of the stock itself, represented by beta, the systematic risk. So for example, for stock 1, what information we have is, in general, say the risk-free rate is 3%. The risk-free rate here could be like the treasury bond rate for 1 year, 3%. Yep, it's a market-driven number, right? You have nothing to do with the stock itself. Second, you have the market return of say 10%. So next year the market return could be like a 10%. It is a market information, right? And lastly, what you have is the beta or the systematic risk for stocks is 1.2. Yep. So with that 3 pieces of information, you have to calculate the fair rate of return you may expect from your investment in the coming period. So the formula for CAPM is that the expected rate of return equal to risk-free rate plus risk factor for the stocks, systematic risk factor, the beta multiplied by market return minus risk-free rate. So to summarize, I can tell you that, first of all, the market return minus the risk-free rate is called the market risk premium. Okay, The beta multiplied by that factor, the market risk premium factor called risk premium for a given stocks. Yep. So you can imagine that the higher the risk, beta here will be bigger, and therefore the risk premium will be higher. And it makes sense, right? If you have to buy a risky stocks, you should expect to receive a better rate of return. Yes, that notion coming from this part of the equation. Okay, so now let's put things into work. So now risk-free rate is 3%. 3%. Okay, like in the previous problem, you can put it 3% here, or you can put it 3. But keep in mind that if you put 3, it means everything in percent. Okay, 3 plus beta of 1.2 multiplied by market return of 10. Again, if you put here at 3, you must keep here at 10. Okay, and then minus of course 3. Sorry. Okay, and therefore the rate of return you expect from the stock 1 is 11.4%. Okay, now if you want to keep it everything as percent, here's what we do. 3% plus beta of 1.2 multiplied by 10% minus the risk-free rate of 3%. So it also give you what? 11.4. Or if you want to do it in that way, like a 3% is 0.03, right? Plus beta of 1.2 multiplied by market return of 10%, which is 0.1, minus the risk-free rate of 3%, which is 0.03. Yeah, it also gives you the same thing. So depends on what way you want to do, you know. Okay, so finally I can give you another example. 3% rate, beta is 2, and market return is 10%. So you see that for the same market condition, if the beta is higher, most likely people will require a better rate of return. So here we go, equal to 3% plus 2 beta multiplied by 10 market return minus free rate of 3. Yep, so 17% required. It makes sense because this, the second stock, is way riskier. So we should expect a better return than the first one. Okay, finally, I think there is a question for something like you calculate the beta of a portfolio. So assuming that you have 3 stocks in your portfolio, stock 1, stock 2, and 3, the beta for each stock is right here, 0.6, 1.1, 1.5, and the weight for each stock in the whole portfolio is 50%, 10%, and 14%, and of course all of them will sum up at 1, right? Similar to the situation where you have, where you have the market condition, you know. Yep. So what we do is the weight here equal to, now it equal to the beta of a portfolio, the beta of portfolio equal to the weighted average of individual stocks. So how to calculate it? You will take this column multiplied by the weight column, okay, and sum them up. So over here we have 0.6 multiplied by 50%, you have 0.3. This one equal to 1.1 multiplied by 10%, it is 0.11, and finally this one equal to 1.5 multiplied by 40%. Okay, so each stock contribute that much to the portfolio beta. So the total portfolio beta equal to the sum of individual components. So here we go. For this portfolio, the beta for it is 1.01. So even though some is higher than 1, some is lower than 1, but eventually on average the portfolio have beta of 1.1. Okay, thank you.